Hi everyone, welcome back. We're going to look at some examples of how to use queues in this lecture. It's a little bit of an odd one here. There's a lot of different examples of, of things for queues. A lot of them come from operating systems and things in computer science where you're waiting. For example, well, let's just look at these examples. Some of them you haven't seen yet, so it's a little tough to give you some of the computer science examples. So we're just going to look at example here. It's a little convoluted, I think, this particular example, but follow me, and I think you'll see that it does work. All right, so we're going to look at how to do coded messages. So we're going to use a queue to help us encode and decode messages. So a Caesar cipher encodes a message by shifting each letter in the message by a constant amount k. So if k is 5, A becomes F, B becomes G, etc., etc. This is extremely easy to break, right? So we can do letter frequencies and things like that, and we can very quickly figure out what the words are, what the letters map, what the mapping is. It's super, super simple to break. So an improvement to how to, or a way to improve this, although I'm just going to say this in case any of you guys are ever thinking about doing any cryptography, do not do this. This is really not any better. All right, but this is just the example, okay? This is not a good way to do this. All right, so an improvement can be made by changing how much a letter is shifted depending on where the letter is in the message. So the first letter we shift a certain amount, like 5. The second letter we shift 3. The third letter we shift 7, etc., etc. And so every letter we have a shift that's different, okay? So a repeating key is a series of integers that determine how much each character is shifted. For example, we have this repeating key 317425. So the first character in the message is shifted 3, the next one 1, the next one 7, and so on. So when the key is exhausted, we'll just start back over. So we'll shift the first one 3, second one 7, second one 1, third one 7, fourth one 4, fifth one 2, sixth one 5, seventh one we'll go back and do 3, eighth one will be 1, etc., etc., etc. So we're going to repeat. We're going to go through the key, shift, different amounts, and then we're going to go back to the beginning and we're going to shift again. Okay? So that's how that's going to work, and that's important to understand that because it plays into how we're going to do this. So when we encode and decode the message, it's going to look something like this. So here is our message in the encrypted version. Here's our key, 314725, 314725, 314. So we're going to repeat the key again and again and again. So the first one we're going to shift 3, the second one we're going to shift 1, 7, 4. And so it's going to map, this encrypted message is going to map onto knowledge is power as the plain text message, right, using this key. All right, so how are we going to do this in code? So the way we're going to do this in code is we're going to implement this as a queue. So instead of repeating, if you look back at this example, we repeated everything again and again and again. So what we're going to do with our queue implementation is we're going to push 314725 on the queue, right? So that means that the front of the queue, the first element we're going to pull out is going to be the 3, and then the queue order is going to look like 314725, right? So the back, the end thing is going to be the 5, okay? So what we're going to do with the queue is we're going to pull off the front of the queue. We're going to pull the 3 off. We're going to use it, and then we're going to push it back onto the back of the queue, right? And what that's going to what that's going to do is it's going to do basically exactly the same thing. So we're always going to pull a number off the queue, the front of the queue, we're going to use it, and we're going to push it on the back of the queue. And if you think about how that's going to shift the letters around, the numbers around, it's going to work exactly like this mapping that we have here, except we're going to do it in a queue. So let's look at the code for this. So we have our key 5, 12, -3, 8, 9, 4, 10. We have our strings encoded and decoded. We have our string message, all programmers are playwrights, and all computers are lousy actors. This is our string message. So we're going to have a queue here, which again is going to be implemented because this is the Java collections queue. So we're going to instead of newing up a queue, we're going to new up a linked list. Remember, this linked list implements this queue interface. So we're going to implement two queues, an encoding queue and a decoding queue. All right. So we're going to stick these things in. We're going to go through and we're going to go from 0 to key length, right? And we're going to add these to the queue. So if you look at this code, encoding.queue, encoding.queue.add, we're going to add 5 because that's the 0th, and then 12, and then -3, and then 8, -9, 4, 10 in that order, right? So now when we pull off the queue, right, when we pull or when we remove, we're going to get them in the same order that we put them on, right? We're going to get 5, 12, -3. So let's look at when we encode our message. We say key value equals encoding queue.remove. So remove the first one off the queue, which remember is going to be the 5. It's the first. It's FIFO, right? First off, first on, first in, first out. So the first one we put in was the 5. We're going to get the 5. We're going to encode this by adding the key value to the character, which again, if you remember characters, we have ASCII, and so we can. It's a number. Characters are numbers. We just add to them, and then it goes, plus or minus. And so then after we finished encoding that character, we're going to add that key value back to the end of the queue. So we pull it off the front, we stick it on the, we use it, we stick it on the back. So then we're going to have the encoded message, right? Now to decode it, we're going to do exactly the same thing. So we're going to start with the first character. We're going to pull off the back of the queue, or the front of the queue. We're going to decode the opposite, the inverse of what we encoded with the subtraction. And then we're going to push that on the back of the queue. And that is actually going to decode our message. So that's our encoding, our decoding, and we use the queue to hold the key, and that makes the key kind of cyclic, right? It's in a circle. So the key is like a circle thing that we kind of go around and around and around. Pop off the front, we push it on the back. If you think about it, it's like people getting in a line, you get your turn, you go back and you get back in the line again, and you get your turn again. It just goes around and around and around in a circle, right? All right. So here's our UML diagram for this. We have our linked list, which implements the queue interface and has a generic. We implement this linked list integer, and it's used by this codes class. So that's the end of the lecture. That's an example of how to use a queue. Queues are pretty straightforward to use. In real life, you use queues quite a bit. So this data structure makes a lot of sense to people. Hopefully you won't have any problems with it. In the next lecture, we're going to look at some implementations of queues. So come back.